Hi, everybody. It's Mrs. Woolley. Thank you so much for joining me. This is our second strategy we're looking at for solving quadratic equations, and it's based on factoring, which is a great review from last week's deck assignment. So after you factor, you're going to use something called zero product property. I abbreviate that ZPP to solve for the solutions to this to a quadratic function. And what ZPP says is any way that the only way that you can get a product of zero is if at least one of those factors is equal to zero, because any non-zero number times zero gives you the product of zero. So what we're going to do is we're going to, first of all, make sure that our equation is written in standard form, and that means that it would be set equal to zero. Then we're going to factor the quadratic, set each of the factors equal to zero, and solve to get the solutions. So there are synonyms for solving or solution, and those synonyms are called the zeros, the x-intercepts, or sometimes they're also referred to as the roots. So in order to apply this process, we're going to use our first example, n squared plus 7n plus 10 equals 0. We can already see that this equation is set equal to 0. So the next thing we're going to do is factor this equation using our guess and check method. So the only way to make n squared is n times n. Now I'm going to look at all the factors that multiply to 10 and that sum to 7. So I know 1 times 10 is 10, 2 times 5 is 10, 3 doesn't go into 10, 4 doesn't go into 10, and I am back at 5. So if I look for a sum of 7, I know that my factors are n plus 2 and n plus 5. I can always check that by using FOIL, multiplying back out, and I'll see it makes my original polynomial. So now that I have factored this polynomial, now I'm going to apply ZPP, which means to set each factor equal to 0. So n plus 2 equals 0. I subtract 2 from both sides of the equation, and I have n equals negative 2. For my second solution, n plus 5 equals 0. I'm going to subtract 5 from both sides of the equation, and I'll get n equals negative 5. So I have two solutions, negative 2 and negative 5. So remember the synonyms here, one of them is x-intercept. So if you think of this as a graph, this is where this quadratic or U-shaped curve touches the x-axis at negative 2, 0 and negative 5, 0. So that's another way to write that solution as an ordered pair. Okay, so next we are going to try a second example. And that second example, and I apologize for that, our second example will be solving by factoring. And this time we see on the right-hand side that we don't have 0. So in order to solve this, the first thing we need to do is add 5 to both sides of this equation. So now we have x squared minus 6x plus 5 equals 0. And the only way to make an x squared is x times x. And now I'm going to list all the factors that multiply to 5 and add to negative 6. Since my product was positive and my sum is negative, I know signs are the same, and both factors have to be negative. So I'll just add x minus in both of my parentheses. So my list of factors are 1 times 5, 2 times 3, 4 does not go in evenly, and we're back at 5. So I can see that sum would be negative 1 and negative 5. So now I have my factors. The next thing I'm going to do is set each factor equal to 0 using zero product property and solve. So when I have x minus 1 equals 0, I add 1 to both sides and I get x equals 1. My second factor, x minus 5 equals 0, I add 5 to both sides and my second solution is x equals 5. And so I could write this as an ordered pair if I wanted, because these are also known as the zeros, the roots, and the x-intercepts. So my solutions are 1, 0 and 5, 0, or x equals 1 and 5. All right, so our next example will be our most challenging example that we factor, and that will be when a does not equal 1. So in this example, we have 10a squared plus a minus 3. And I want to remind you that the coefficient of your a squared is a. The coefficient of the linear term is b, and the constant is c. So a times c is a negative 30. And we're looking for a pair of factors that when they give you a product of negative 30, that same pair gives a sum of a positive 1. So we're going to go ahead and make an organized list of factors, and we want to remember that signs will be different. That's the only way to get a negative product when you're multiplying two numbers, and the larger factor will be positive because the sum is a positive 1. All right, so I have negative 1 times 30, negative 2 times 15, negative 3 times 10, 4 does not go in, and then negative 5 times 6, and I can see that then I would be back at the starting place because I'd have 6 times negative 5. So which pair gives me a sum of 1? Well, negative 5 and 6. So that is the pair that I'm going to use. And if you remember, I'm going to bust that a up and rewrite it as negative 5 and 6. All right, now I'm going to group the first two terms and group the last two terms. You can see 10a squared minus 5 share a common factor of 5, so I'll factor that out, and I'll have 2a minus 1. And then on the second pair, I have 6a minus 3, and I can see that they share a factor of 2, so I will factor that out. So I can see my common factor of 2a minus 1, so I'm going to factor that out, and what is left is 5. Now, if you'll notice, I made a mistake here. This should have been an a. I'm going to go back and add that, and I factored out a 5a. So then I would have a 5a plus 3. Sorry about that. Now, if I was to multiply that back out using FOIL, it would give me the original polynomial. So now I have to apply zero product property, which means to set each of these factors equal to 0. And I'm going to rewrite each of those expressions up here and write them as equations set equal to 0. So if I rewrite the first equation, 2a minus 1 equals 0, add 1 to both sides, divide both sides by 2, I get a solution of a equals 1/2. And then I take the other expression, write that in this equation, 5a, and it should say plus 3 equals 0. And I'm going to subtract 3 from both sides and then divide both sides by 5. And I will get a solution of negative 3/5. And so I can write that solution set as 1/2, comma, negative 3/5. So I hope you enjoyed this video, and the last video will be solving by using the quadratic formula. And the quadratic formula always works. It's a little longer method because you have to apply a formula. And the other thing is you need to memorize the formula in order to be able to apply it. So that is something that would be required of you probably in geometry and algebra 2, that you actually memorize the formula. So please look at the next video for a little help on using the quadratic formula. Thank you.